Okay, so geometry, semester 2, we're continuing with chapter 6, okay? We did the first 3 lessons already. So if you recall, chapter 6 is about quadrilaterals, okay? Quadrilaterals are 4-sided figures. We already looked at parallelograms, okay? And that's a special type of quadrilateral, so it means it has 4 sides where opposite sides are parallel. Okay. Within parallelograms, we have special types of parallelograms, okay? So they would be a rhombus, a rectangle, and a square. Okay, so a rhombus is a parallelogram, which means it has 4 sides. Opposite sides are parallel, and it has 4 congruent sides. Okay, so these sides are parallel, these are parallel, but then they all 4 are the same length. Okay, a rectangle is a parallelogram with 4 right angles. So rectangle, right? These 2 sides are parallel because it's a parallelogram. These 2 sides are parallel because it's a parallelogram. But then these are 4 right angles. And then a square is a parallelogram with 4 congruent sides and 4 right angles. So all the properties of parallelograms that you already learned apply to these 3 figures because they're all parallelograms, okay? So a square, when you think about it, so these are parallel, these are parallel, okay? 4 congruent sides, so this side is congruent, these are all congruent, which makes it a rhombus, and then these are right angles, which makes it a rectangle. So a square is a rhombus and a rectangle, okay? So if we look at the bigger picture, we have quadrilaterals. Within quadrilaterals, you have special quads that are parallelograms. And then you have rhombuses. And you have rectangles. And then this overlap here is your squares, because that's saying that it's a rhombus and a rectangle. Okay? So 3 new figures. They are parallelograms, which makes them quadrilaterals. So if it's a quadrilateral, so you can use the properties of quadrilaterals and parallelograms on these 3, because these 3, rhombus, rectangle, square, are quadrilaterals and parallelograms. Okay, they have some of their own unique properties, but they are also parallelograms. So if I say a rectangle is a square, this would be sometimes true. It's not always, but it's not never. It's sometimes true. If we say a square is a rhombus, that is always true. Okay? All right. So if I tell you you have a square, QRST, what can we decide about this figure? Right? It's a square, so it has 4 right angles. It has 4 congruent sides. Because it's a parallelogram, we can say opposite sides are parallel. Because it's a parallelogram, you can say opposite angles are congruent. You can say opposite sides are congruent, even though that's already implied up here. Okay? All because it's a parallelogram. You can say consecutive sides, or consecutive angles, sorry, are supplementary because it's a parallelogram. And you can say the diagonals bisect each other because it's a parallelogram. Okay? So, you know that a rectangle is a parallelogram because it tells you in the definition. And it has 4 right angles by definition. So then any quadrilateral with 4 right angles is a rectangle. Because if it has 4 sides with 4 right angles, it makes it a parallelogram. Okay? So we have some corollaries. You have the rhombus corollary, which says a quadrilateral is a rhombus if and only if it has 4 congruent sides. So you can eliminate the parallelogram part. The rectangle corollary tells us that a quad is a rectangle if and only if it has 4 right angles. And the square corollary tells us that a quadrilateral is a square if and only if it's a rhombus and a rectangle. Okay? So you can take out the parallelogram part and know that if it's a quadrilateral with 4 congruent sides, it's a rhombus. If it has 4 right angles, then it's a rectangle. Okay, if it has 4 congruent sides and 4 right angles, then it would be a square. Okay. So EFGH is a rectangle. So I'm going to draw that. Okay? And I'm just going to label it EFGH. It's a rectangle, so you know that this is a right angle, right angle, right angle, right angle. Go with that. Then you're told K is the midpoint of FH. Well, so here is FH, so we'll put K here. It's the midpoint, so it tells us this piece is congruent to this piece, okay? Let's draw in. So let's draw in EG, okay? Then you're told that EG is 8z minus 16. We're going to be able to find EK and GK. Okay? Since it's a rectangle, you know it's a parallelogram, which tells you the diagonals bisect each other. Okay, so then you know that EG is a diagonal, so you know that's equal to twice the length of EK because it's been bisected, so EK and GK are equal. So you know EG is 8z minus 16, that's twice the length of EK, so we're going to divide by 2. And we get that EK is 4Z minus 8. We don't know what Z is, so that's fine. You also know that GK has to equal the same thing because the diagonal has been bisected. Okay? All right. 3 theorems, okay, from this lesson. They're in your notes, so I'm not going to necessarily write them down, right? But they're here. So theorem 611 says parallelogram is a rhombus if and only if its diagonals are perpendicular. So rhombus means the sides are congruent. So then congruent and parallel sides, AC and BD have to be perpendicular. They have to form a right angle then, if it's a rhombus. Okay, if you have a parallelogram that's a rhombus, then if and only if the diagonals bisect a pair of opposite angles. So A and C are congruent, okay, because they're opposite in a they're opposite angles in a parallelogram. So A has been bisected and C has been bisected. And B has been bisected and D has been bisected. Then for rectangles, a parallelogram is a rectangle if and only if its diagonals are congruent. So not just bisected, but they're congruent in a rectangle. Okay? So you can see those actually in the notes themselves. So ABCD is a quadrilateral. Okay, all you know is that it has 4 sides. The diagonals meet at point D. No, point E, sorry. And AE equals BE equals 6. Is this a rectangle? Okay, so you know it's a quadrilateral. So I'm going to draw just a 4-sided figure. Okay, we know we label them in consecutive order. So we're going to say this is A, B, C, and D. You know the diagonals meet at point E. So here is a diagonal, here is a diagonal, and we're going to say this is point E. You know AE is 6. You know BE is 6. So it tells us that these 2 pieces are congruent. Okay? We know with a quadrilateral, the diagonals bisect each other. So that tells us that AE is equal to CE and BE is equal to DE. So this is 6 and this is 6. Okay? So then you know that AC is AE plus CE, which is 12. And you know BD is BE plus DE, because that's just the line segment addition, which is 6 plus 6, which is also 12. So that tells us that the diagonals are congruent. So ABCD is a rectangle because the theorem says it's a quadrilateral with diagonals that are congruent, so therefore it is a rectangle. Okay, so that is lesson 6.4.